So the next few examples are area of a segment. And just to remind you, that means your area of a sector minus the area of the triangle, which equals the area of the segment. So the first thing we need to talk about real quick before we do that is that we need to talk about how you find the area of a triangle. Now, when you learn that skill, you always learn that it was half the base times the height. Now, in order for that to be true, the base and the height have to be perpendicular, which means you have to have a 90-degree angle of some sort within that triangle. Now, you're not always going to have a 90-degree angle. And so the formula that you could also use, which is used in IB very often, is half of A times B times sine of C. Now, where do these letters come from? So the A is going to be one of your radiuses or one of your sides. B is going to be the other radius or side. And C is technically this side over here. But we don't actually want side C. We want the angle of C. So we want angle C, okay? Meaning the angle that you are provided, okay? So again, half of AB sine of C. So for the problem that we're going to complete, we're going to find the area of the shaded segment, and we're going to round to the 10th. So for this number 4, this is the drawing we're going to work with. We have a radius of 8 centimeters, and we have a central degree of 120 degrees. So first you have to find area of the sector. So remember, area of a sector is theta divided by 360 times area, which is pi r squared. So my theta is 120 divided by 360 times pi radius of 8 squared. I'm going to go ahead and simplify that. 2 times by 64 pi. And then you want to go ahead and simplify this as much as possible into a fraction. And just confirming my answer, 64 thirds pi. Now, technically, you should have a label on this, but we'll worry about the labels at the end, okay? Now I want to find the area of the triangle, okay? So I want to take out the triangle part. So area of a triangle, remember, is half AB sine of C. So A and B are our sides. Well, this is 8, that's listed. What's my other side going to be? My other side is also going to be 8. Because if this radius is 8, the other radius has to be 8. And then sine of my angle for C, which is going to be 120 degrees. Then I'm going to multiply half of 8 times 8, simplifies to 32 sine of 120 degrees. Okay, so I have area of a sector, I have area of the triangle. Now in order to find the area of the segment, I have to subtract. So area of a segment equals the area of the sector minus the area of the triangle. So 64 thirds pi minus 32 sine of 120 degrees. Now you're going to have to type that in your calculator, and every calculator is different, and we've discussed this and we've talked about all the different ways that each calculator has to be typed. So it'll be a little bit of trial and error if you don't remember, but the correct answer when rounding to the 10th would be approximately 39.3 centimeters squared. Okay. So I can't necessarily show you how it would work because I only have one certain type of calculator, and we've discussed how you have to type certain things like sine, cosine, and tangent, and your pi button is on your calculator as well. So trial and error, but your answer should be 39.3 centimeters squared. So we're going to go ahead and solve for number 5, which will go a little bit faster just because we're a little bit more used to it. So area of a sector. So we have 60 divided by 360 times pi times 18 squared. Remember, 18 squared, 324 pi. Simplify that, and it comes out to a nice number of 54 pi. Then I'm going to find the area of the triangle. Half of 18 times 18 times sine of 60. Half of 18 times 18 is 162 sine of 60. And so to find my area of my segment, remember we take the area of the sector minus the area of the triangle. So I have 54 pi minus 162 sine of 60, which when rounded to the 10th comes out as 29.3 inches squared. So that is how we do number 5. Okay, I have one more to do just for practice. Okay, number 6. Okay, so area of a sector. Okay, now what is my degree? The only marking I have is this box. Now remember, box means 90. So 90 divided by 360 times pi times 4 squared. Four squared is 16. Multiply and simplify, and this one also comes out to a nice 4 pi. Then I find the area of my triangle. Half of 4 times sine of 90, which is 8 sine of 90. Now to find my area of my segment, we take the area of the sector, subtract the area of the triangle. So 4 pi minus 8 sine of 90, which is approximately 4.6 meters squared. And that is how you find the area of segments.